All right, so we're going to pick up from number 5 of your homework from yesterday. Okay, we're going to pick up from 5 of your homework.
We get some homework today.
Yes. Okay. So number 5 of your homework says how much of a 95.6 milligram sample of thorium-230 would remain after 32,000 years. Okay. So we're going to solve this out the same way. We had those 2 equations yesterday that were extremely important. We used them in unison. Okay. And you actually had to do we're going to do number 5.
Where's LN at here?
LN is going to be next to, next to the fraction. All right, so we got our 2 equations. Our 2 equations from yesterday were T1/2 equals ln2 over K. ln2 is equal to 0.693. And our other equation, the one I posted yesterday. Yes. I put the URL on there yesterday. I can't. It's the last thing I posted. The video is the last thing I posted, okay? I just posted the atoms. Riley had just asked for all the notes together, okay? That way they didn't have to go back through the PowerPoint to find the slide with the equation and things like that. So that's the notes that we've just been going over, okay? But the URL, the video is right there, the top one, rate of decay. All right, so our other equation was ln of AT over AO equals negative KT. Yeah, we have to do 5 of them. So on this, we're going to use this one. Then this one gets a little bit harder as you have to do a little bit of work, okay? Are we going to use our half-life equation or our rate of decay equation? Half-life is T1/2 equals ln2 over K. Rate of decay is, I'd use my rate of decay. Well, not first, that's all. Well, that's what I would use. So I have T1/2 equals ln2 over K. So I would use ln of A. And sometimes I think on like the AP exam, I think it's given as AT. But sometimes it's just A over AO. I don't know. Because ln is different, okay? Because ln is different of how it goes in the calculator. Ln, if you remember from yesterday, if you watched the video yesterday, this ln of A over AO is always going to give you a negative number, and that's why you have negative KT in there, okay? So AO and A, those are concentrations, or they could be percents, or they could be grams, okay? So I'm sorry I didn't specify that yesterday. So my ln, am I looking for A or AO in the problem? Yes. I'm looking for A because I'm looking to know how much is going to remain. So I'm going to put X in there for A. Over, what was it, 95.6? 95. The units don't matter. Just my answer will be in milligrams, okay? Now here's my problem. What's my K? How do you find K then? But so I know I gave you on the homework, I gave it to you, the half-life is 8,000 years. So I'm going to have to use my T1/2. Remember, T1/2 stands for half-life equals ln2 over K. So I know I'm going to have 8,000 equals, these 2 equations are used in unison pretty much all the time. 693 over K. Does that make sense to you? You too? Well, let's pay attention. Let's pay attention so we don't get behind. Let's pay attention so we don't get behind. So I have my two equations. My two equations that I'm going to talk about are, here's one, ln of A over AO equals negative KT. And my other one is T1 half equals ln2 over K. I'm going to use them very often, okay, together. Because like in this question, I'm doing question number 5, it wanted to know how much remains. But I have two variables, okay? So I didn't know A, so that's what I'm looking for, how much remaining at some time. And I didn't know K. But I knew the half-life of thorium, so I used this equation to find, these two Ks are the same K, okay? So I've used my half-life equation to find, I told you the half-life of thorium was 8,000 years, so I used that to find K. So what is K? Equals, number 5, 8.6, negative fifth, I hope. And my units there will be inverse time, okay? So that was, we were in years, weren't we? I gave you the half-life was in years. So now, I use this half-life equation, okay? T1 half equals ln2 over K. Just, it's going to be given to you. You got to know when you're talking about rate of decay, you're going to use these two equations, okay? We're talking about how much something decays. You're looking for a concentration or a time. You're going to use these two equations right there, every time. Okay. What? So, but I know T. So this is, it says 32,000 years. So this is 8.6 times 10 to the negative fifth times 32,000.
Otis, please go to the art room. Otis, please go to the art room.
No, this is where it's a little bit different, okay? And this is where this math is higher. You know, you multiply things. When things are multiplied together, you divide to get rid of it, correct? When things are subtracted, you add. You do the opposite. The opposite of ln is the E button. Now, not EE. It's the E button. It's second ln. Okay? So you would E this side, the natural log. So you're going to E this side, and you're going to E this side. Well, E to the ln cancels. So you're left with X over 95.6 equals E to the negative, somebody do these two, do 8.6 times 10 to the negative fifth times 32,000 in your calculator. But just let's stepwise it. Do 8.6 times 10 to the negative fifth times 32,000 first. Negative 2.75. Okay. Now you need to E. It has to be negative. So you're going to use E 2.75. Are you paying attention? Follow along. Well, you're going to get less. You're less getting it when you're not following along. All right, watch the video. Not leaving, got canceled. What? I haven't messaged everybody yet. I will. So you got 90. So now you're left with X over 95.6 equals, what'd you say?
6.8 or 6.38.
So 6.38. That's in the negative 2. Significant figures, yeah. Well, but we're going to treat it as 3. Now just to get your answer, you just do 95.6 times that answer. $6.09. So your answer is 6.09. Now, what were my units? Yep. 6.09. Said 6.09, correct? Milligrams. And that's it. So E is the opposite of the net of Ln. Okay. So when you have the E, a big mistake people make is they forget to make it negative right here. If you do E to the positive number, you're gonna get a huge number. Okay. This number right here should typically be small. Should typically be small.
All right, the first one, you start out with 50 grams and it goes to 14, like, it goes to 12.4 grams in 14.4 seconds. So you use the second equation, right?
The ln of A over first, and then go back.
So you don't have, it says, the question is what it's half-life. How can I use that one if I don't know what K is? I can't find K without the half-life.
But I can find K from this equation, can't I? So let's pay attention for a second. Let's do number 1 together, okay? Just as a review. So I've got my 2 equations. I'm not going to go over those again, okay? I'm not going to write them down again. So number 1, we've got this information, okay? We've got ln of A over AO equals negative KT. Do I have concentrations in this? I have grams. It's concentration, same thing, okay? So I'm going to use that equation first. So ln, remember ln, when you do ln, the smaller number always goes on top. So ln of 12.5 over 50.
I didn't realize that it gave me.
Didn't get time. There you go. Equals, I'm looking for K. I'm going to use it second, okay? Because I can't use the half-life equation on this one. Yeah, I can't use the half-life equation because I don't know half-life or K. So negative K, and time was 14.4. Remember, when you use ln, the smaller number always goes on top. Now, your K is not going to be negative, okay? Now, it's negative because when you put ln of 12.5 over 50, you get a negative number. Mm-hmm. So you do ln of 12.5. No. What? What, 14.4? The ln? Okay, it will. Your calculator's automatically going to open parentheses, so just make sure you close them, okay? I'm sorry. So you do ln 12.5 divided by 50, close parentheses, divided by negative 14.4. It'll still do it, yeah. I just don't like that you can't see what you're plugging in. Does that make sense? That's what I don't like about that calculator. I mean, your computer calculator will work. See, that's...
So when you get this answer for this would be negative, but it won't be negative.
Yeah. Let me find my masks. I didn't know my wife bought this one for me. I knew I had 3. I like this one best. Oh, me, look up with me. Okay, this one I don't like this one. So when yours, you would do parentheses 12.5 divided by 50, close parentheses, second, that open parentheses. You would do parentheses 12.5 divided by 50, close parentheses, ln. Okay. And that can simplify the left side for you.
Okay, then I gotta
Divide by 14.
divide this.
Negative 14.
Negative, okay.
Because you want your answer to be positive, and that number you just got was negative.
Mine's negative.
Make it positive. What is it? What'd you get? 0. You got 0 point what? 0 point what? 0.09. 1, 6. Okay. And now my units.
Wait, you
Right. My unit's always going to be inverse time, so my time was second, so second's the -1. Now, I can go use my half-life equation, can't I? Because I know one of the variables. So T1/2 equals 0.693. That is ln2. And what did you get your half-life to be? What? 7.22. What are my units of? Nope, just seconds. This answer right here?
Yeah.
Yes, ma'am. What? I processed it. You know, I'm a slow processor. All right, let's do number 7 together, okay? It's on Google. I'm sorry, that's what you're confused about Google Classroom. I'm sorry. Rate of decay. I'm sorry. All right, let's do number 7. What? What answer? What? Okay, I won't answer that yet. It's 0.693. That's ln2. So the half-life equation is ln2 over k. Always 0.693. Yes, ma'am. We don't have ln, so I would do. I don't have ln on this one, so I would just do 0.693 divided by 0.0963. What'd you get? That's all right. 7.19. That's close. That's fine. Yeah, that's fine. That's close enough. All right, we ready to go do number 7? You up now? Okay, I'm sorry that I wasn't clear with you a while ago. I thought you were struggling with where we got. We're there now. Same wavelength. No, I don't want to say. All right, so number 7. How much of a 35.8 milligram sample of thorium-230 would remain after 1,850 years? So, what? Yes. Yeah. All right. So we're going to use, I got my 2 equations here, don't I? Now, here's the wonderful thing about this. Have I already found K in a previous question for thorium-230? That was the 9 point. Mm-hmm.
Okay, quick question before we do number
Yep.
this event number 2 is the same way, is the same setup way we're doing. If you looking for half
Yeah. Yeah. So this is where you got to work smart, not hard. On number 7, okay. Number 7, we're still talking about thorium-230. K is the same all the time for thorium-230. So on number 5, we found, well, actually, number 6, it asked for what is the rate constant of K. Okay. So we've already found that. We found it to be K equals 8.6.
Go ahead, do all.
8.6 times 10 to the negative fifth. Once we do 7, you can do 5, okay? But we've already found K previously, okay? On a previous question, we were asked to find K, so I don't need to find it again. Let me show my work. So I've given a concentration here, aren't I? I got that from 5, yes. I got that from number 5. And it's also the question for number 6 also. Years to the negative 1. Years to the negative 1. So I'm gonna use so now I don't need to use my half-life equation, do I? I'm done with it. Half-life is either used to find half-life or to find K. At that, you're done with it. So Ln, now, do they give me AT or AO? Yeah, they give me AO. So I know that that's still X on the top. It says how much will remain after, okay? Yeah, it's telling you that it's going to be, yes. If it says how much will you start with, how much you initially have, that would be your AO. If you look for it. So now this is 35.8. My wonderful writing. I cannot wait to get my smartboard fixed. Did y'all? Oh yeah, yesterday there was a big delay. He was trying to fix the smartboard. Equals. I found K, so negative 8.6. It has to be negative, okay? Because it's negative KT. It will really throw you off if you don't have a negative number whenever you do your E. So what's my 1,850 years? Or 500 years? 18,500 years. Done to me. So now I'm going to E each side, okay? I'm going to E each side. I'm going to E each side. That's the second LN button. It's the second LN. Yeah. Okay. So E to LN cancels, okay? So I'm left with X over 35.8 equals, Gabe, what was this simplified down? Can you do it again? 1.591. So negative 8.6 times 10 to the negative fifth times 18,500 is this. On which side? Where I'm at right now, I haven't done anything yet, okay? All I did right now was I just multiplied this times this, okay? Does that make sense? And that's 1.5. So now, K times time. Mm-hmm. Now I need to get rid of E. Now E is the button on your calculator, okay? So you would write, now you're different, okay? You're different. I'll tell you in just a second. You would do second LN negative 1.591. You would do the opposite. You would do negative 1.591 second LN, okay? Your programming's backwards on that. Negative 1.591 and then hit second LN. Mm-hmm. 0. Point what? 0. 0.04. Is that what you got? 0.4. And now I'm left with, so that equals X. 2.7? Oh, 204. Sorry, sorry. You know, I don't always hear very well. I erased that 7. So now we're left with X over. And now you just multiply them together to get it, don't you? If you're looking for a O at some point in time, it's the same thing, but you would just divide instead of multiply when you're done. Are you all good? Yeah. 7 point. I probably only need 3 significant figures. 3.0. 7.30, and my units were what? Milligrams? Yep. That's it. So that's the only thing that was really different about today than yesterday, and that's an M, not an N. One thing that's really different about yesterday than today was you have to use the E button.
Last button's like, there is 14.4 grams remaining.
Yes. So the only thing
How
you,
many did you start with?
yeah, the only thing would be different here is you would say you have 35.8 over X. The only thing would be different is you would do, yeah, you would divide instead of multiply there.